Welcome to Chemistry 1451, Aspirin synthesis. In this experiment, we will react salicylic acid and acetic anhydride in the presence of phosphoric acid. This is known as esterification. The products will be aspirin and acetic acid. The estimated time of completion is 2 hours. As always, make sure to comply with all safety regulations. There are two basic parts to this experiment. Part A is aspirin synthesis, and Part B is testing of the aspirin. Before beginning the experiment, you will need to set up a boiling water bath and an ice water bath. For Part A, you will also need a 125 ml Erlenmeyer flask, a 150 ml beaker and one 30 ml beaker, one 10 ml graduated cylinder, a steering rods, a rubber policeman, a clean dry watch glass, and pipettes. Later, you will need to assemble a filtration vacuum setup. Make sure to place a beaker with 40 ml of water and another beaker with at least 10 ml of DI water in the ice water bath. Weigh 2 grams of salicylic acid and place it in the 125 Erlenmeyer flask. Make sure to record the actual amount you weighed. Add 5 ml of acetic anhydride. Slowly add 5 drops of 85% phosphoric acid. Stir the mixture with a stirring rod. Place the flask in a boiling water bath for 5 minutes. Make sure to constantly stir the mixture. Remove the flask from the water bath and add 5 ml of DI water, while holding the flask by the downdraft hood at your bench. Continue to stir until the contents are cool at room temperature. This takes about 15 minutes. Add 40 ml of ice-cold water. Place the flask in the ice water bath for 5 minutes. Now we're ready to start filtrating our solution. Using 2 circles of filter paper instead of 1 can help decrease loss during filtration. Remember, we're trying to get the highest yield possible. You can also rinse your flask with cold DI water to reduce the loss during transfer. Wash the aspirin crystals with 10 ml of cold DI water. Continue to pull air through the crystals in the Boschner funnel for about 10 minutes. Transfer the crystals and the filter paper to a dry paper towel. Allow them to sit and dry for 10 minutes. Weigh a dried and clean watch glass. Then, weigh your aspirin product with the watch glass and calculate the mass by subtraction. It's time for Part B. For Part B, you will need 4 clean dry test tubes in a test tube rack, a 10 ml graduated cylinder, a steering rod, pH paper, and a pipette. Test tube 1 will contain 3 ml of 0.15% salicylic acid. Test tube 2 will contain commercial aspirin. Half an aspirin is enough for this. Test tube 3 will contain your aspirin product, and test tube 4 will contain pure acetylsalicylic acid. For test tubes 2 through 4, we will add 3 ml of DI water. Measure 3 ml of salicylic acid and place them in test tube 1. Crush an aspirin and dissolve it with 3 ml of water into test tube 2. Half an aspirin is enough for this. Use a little bit of your aspirin product and dissolve it with 3 ml of DI water in test tube 3. Dissolve a little bit of pure acetylsalicylic acid with 3 ml of DI water in test tube 4. Dissolve all the solids in the test tubes, but be careful with the stirring rod. You don't want to poke a hole in the test tubes. And be very careful to avoid cross-contamination. Clean the rod in between each sample. Immerse the stirring rod in the solution and then touch it to a piece of pH paper. Avoid cross-contamination by cleaning the stirring rod in between samples. The pH for all samples should be acidic. Add 5 drops of 1% ferric chloride to each test tube. Ferric chloride is a purity test. It tests for the presence of salicylic acid. Dispose of the filtrate solution from part A in the non-halogenated waste container. For part B, dispose of all solutions in the test tubes in the heavy metals waste container. Any excess solid aspirin should be disposed of in the solid waste container.